Hello, environmental studies students. We are beginning our last unit of this semester. You've only got 2 weeks left, less than 2 weeks. So we're going to be just doing a brief little unit on water issues and water quality. This is a very tentative calendar for us for the last 2 weeks, but again, I just wanted to highlight that your last day of school for seniors will be on Friday, May 22nd, and so we'll just have a short little unit test on that day. There will be no final exam for this class. We'll just wrap things up, and I want to meet with you guys on Thursday the 21st just to say goodbye and review any questions and check in with you all before we sign off for the year. There's a link to this calendar on my Schoology page, so you can check back and see if I make any changes. So we're going to be talking about water and just some basic questions that we'll be answering over the next 2 weeks. Today we're going to be looking at where in the world can we find water? What are the threats to our drinking water and our drinking water quality? Why would we not have safe, healthy drinking water? And what are some things we can do to help remedy those threats? Look at that later this week. And then next week we'll be moving into kind of comparing our drinking water that comes from our taps and faucets, comparing that to storm water. How are they similar? How are they different? And then just kind of defining a basic thing, which is called a watershed. So my question to you is water important? Is this an important thing for you and for your life? Is it important for our planet? And the answer, of course, is yes. Yes, of course. Water is very important for all living things. And I love this quote by Benjamin Franklin: "When the well is dry, we will know the worth of water." I was reading a book about The Lion King to my son the other night, and it reminded me that if we don't have those basic necessities, like when Scar took over and the Pride Lands and Simba moved away, thinking he had killed his Mufasa, they don't have these basic things. They don't have food. They didn't have water. And then it became really important. So then Simba moved back. But if we don't take care of planet Earth, if we don't take care of our resources, our food, our water, then our world is going to crumble, because all living things need water. So yes, water matters. It's abundant on planet Earth. It's anywhere I've seen estimates from 70 up to 82%. So water is plentiful on planet Earth. It's the blue planet for a reason. We have a lot of water, and it is essential for all living things. Every kind of cellular activity that we've talked about in biology, cellular respiration, photosynthesis, within a more developed body, we've got the diffusion of nutrients into our bloodstreams, and water is the main component of our blood. It's helping to distribute those nutrients. It's helping to remove waste products from our bodies. It's the main component of our cytoplasm in our cells. So all living things need water. If they don't have water, they will dry up. And we've got all these adaptations for plants and animals alike that allow them to conserve water and maintain that water balance within their bodies. So it is essential for all living things. And just to put a little more personal for you, your body, your own personal body, is made up of about 72% water. So you have water within your cells. You need water. If you don't have water, your cells will not make it. And so we need to make sure that we have drinking water available to us, that we can get it from our food sources, and that our body is able to maintain that balance. So it's important to you, it's important to all living things, and it's important to planet Earth. So ever since you were in elementary school, you've been learning about the water cycle. You've slowly learned more and more terms, I'm sure, associated with it. So this is our basic water cycle. If this does not look familiar to you, you should pause the video, and you should make sure that you kind of write things down and draw some pictures in your notebooks. So you have learned, hopefully, about evaporation, and we can see evaporation in the large scale from oceans and streams up into the atmosphere. You can even see it in your kitchen if you're making a pot of pasta. Put water inside the pot, you turn the heat on, and then you start to see that it's steaming. Any of that steam that's now entering your kitchen as a water vapor is a form of evaporation. Okay. Evaporation can also happen through plants we have a different name for that, but it is just evaporation, and it's transpiration. If you want to do a fun experiment, go back out to your sit spot and put a plastic bag around some of the leaves on your tree, and just kind of tie a knot or tie the bag tightly around that branch, and go back in a couple of days and see if there's any water in the bag. Plants will allow for water to escape through tiny little holes, and that's called transpiration. They also soak up any water from the ground up through their roots, and so it's this constant movement of water from the roots up to the leaves. Some of it gets used and some of it will evaporate. If it enters our atmosphere way up high, then or even down low, it will condense eventually. When that air cools, that water vapor will condense and form tiny little droplets. You can see that as clouds. You could see it as fog. But as the water vapor, that warmed up water, and the gaseous water will condense into tiny, tiny little droplets. And if they accumulate together, it forms these much larger clouds. When those molecules get too heavy, then we see that they will fall to the surface, and they can fall and land on any surface. In this picture, it's up on the mountains, but we call that precipitation, and that can come in lots of different forms. We've got sleet, snow, rain, hail would be another form of precipitation. So as it falls back down towards the earth, that's our precipitation. And then depending on where that water lands, it might just replenish the water source like the lake or the stream or the river. Unfortunately, if we add human activity, we could carry some pollutants with it from a water or from a surface source, and that could run off into a stream or a lake or river and pollute it. Our groundwater is actually underground, and we'll talk more about that in a little bit. So this is, again, a pretty basic look at the water cycle. This next picture is a little bit more complicated. Again, feel free to pause so you can kind of explore a little further. But when we look at all of the different ways that humans and human activity and our human population growth are impacting the water cycle, we play a large role in the water that's on planet Earth and the quality of water that we have available to us, and also our use of water. If we're overusing water, that can lead to problems within our communities. It can lead to problems within the ecosystems as well. So again, this is similar to the last one, but it just has a lot more information and showing kind of interactions that water has with living things as well as other non-living things. So what drives the water cycle? Why is this water constantly moving from a body of water on the surface all the way up into the atmosphere and then coming right back down? What's driving this cycle, the movement of water? The sun. And the cool thing, at least I think it's cool, one of the coolest things about the water cycle is to think about water on planet Earth has been here for over 4 billion years. The same water that was on planet Earth 4 billion years ago is the same water that we have today. It constantly is being moved from location to location, or maybe it's stuck in our oceans and it's been there for a billion years. But the same water molecules that were on planet Earth billions of years ago are the same water molecules you and I are drinking, consuming, that we're flushing down our toilets and showering and bathing with. And so really it's our duty to help take care of this water, because it's going to continue to be here in different forms and in different areas of the world as we continue to go. So where is our water located? On planet Earth, we know that the majority of the Earth is made up of water. Where is it? The main thing that you're probably thinking of is our glaciers. Sorry, I'm looking at the picture. As our oceans. Our oceans are the majority of where we can find the water. It's our largest compartment of water. 97% of our water is in our oceans. Lakes and ponds, streams and rivers, it's probably another common thing people will come up with. You might think of snow and glaciers, our ice caps on the globe. Some of you maybe even thought, well, it's in the atmosphere. We just talked about condensation up in the clouds. Maybe it's in the atmosphere. That's true as well. Oftentimes we kind of skip over or don't think about, maybe many of us don't even know what groundwater or aquifers are. This is water that's actually found underground. It's like a pool of water between the rocks underground. And this is actually where many of us get our drinking water. The city of Edina gets its water from aquifers, and we pump the water from underground up to one of 4 drinking water facilities, and they treat the water and clean the water, and then they can distribute it to homes and businesses and buildings. But Edina, again, gets water, drinking water that we use in our homes and buildings from underground. These are called aquifers. And then there's also wetlands, and a lot of people don't necessarily care for wetlands. They're kind of gross, smelly, ugly looking ecosystems for many people. I think they're pretty cool. But there's a lot of water in our wetlands, and wetlands are a really important ecosystem because they actually help to really filter out the water as the water kind of percolates and goes through the soil to help replenish those groundwater aquifers. So that's where we can find water. Now let's look at the percentage and the distribution. As I said before, and I corrected myself to say that the majority of our water is in our oceans. 97% of the water on planet Earth is in our oceans. I don't know if you've ever been to the ocean, but the ocean water is salty. It's salt water, and it is not drinking water. We would never go to the ocean, grab a cup or a glass of water and drink it. That would be harmful to our bodies. It would not taste good. The salty water is not helpful to us as living beings who need water to drink. Yes, it's water, but that salty water is not healthy for us to drink. Okay, there's only 3% of the water on planet Earth that is fresh water. Fresh water means it is not salt water. Okay, now of that fresh water, again, only 3% of the water on planet Earth is fresh water. 97% of it is salty, not accessible or usable in terms of drinking in our body use. So 97% is not usable by humans. 3% is fresh water, so we could actually drink it. However, of that 3%, the majority is not accessible. The majority of that 3% is frozen. Okay, about 70%, it says on here, 68.7% of the fresh water is frozen in our ice caps and our glaciers. Okay, so of all of the fresh water that we have, the very limited amount, most of it is frozen. So this whole bar here, this whole bar in the graph is all representing the fresh water, which is, remember, just 3% of the overall water on planet Earth. 30% of that fresh water is groundwater, so that's pretty good for us at least. And then the surface water would be things like the lakes and streams and rivers. And so that fresh water, again, 3% overall, most of it is frozen in ice caps and glaciers. And there's another percent then, that 30% that goes down underground for us to be drinking. Here's another graph that kind of shows the same thing, just slightly different percentages and different vocabulary terms, but again, representing the same thing, that the majority of our water is salt water. Only 3% being fresh water, about 3%, and most of that fresh water is frozen and inaccessible. So why should we care about this? Why are we talking about water? This is actually one of my favorite units. I think you guys will hopefully learn a lot. Water is important for all of us to survive. And now I'm kind of turning it back into why it's important to us. We need water for survival. It's a human right, a basic human right. All people on planet Earth should have access to clean and safe drinking water. Unfortunately, that is not the case because of the distribution of water and because of the technology required in order to have clean, safe drinking water. We need technology in order to have sanitation, so getting rid of waste and treating water. All of that is really important, and not everywhere on this planet has access to those resources. And so I'm kind of tying this back into your SDG journals that we did earlier in this semester. SDG number 6 is focusing on the clean water and sanitation. I actually took screenshots from this link, but I've got more links posted in the Schoology quiz later. But goal number 6, the clean water and sanitation. Just some facts that are listed on this webpage. Water scarcity affecting more than 40% of people. Okay, although 2.1 billion people have improved water sanitation since 1990, we're dwindling our drinking water supplies, again, growing population size, and that is affecting every continent. Safe and affordable drinking water for all by 2030, which is part of the goal that requires us to invest adequate infrastructure. We need the technology, we need the buildings, we need to be able to treat the water and help distribute that to the people who need it. So again, I've linked this to the quiz later on, so you can go and kind of explore and read up on this if this is something of interest to you. All right, I'm going to quit here for today. We'll learn more about why we should care about this and how it connects to us and our lives here in Minnesota. So just go ahead and finish up some of these questions, and I'll talk to you again tomorrow. All right, have a good rest of your day.